Here are the answers to your 8.3 Settling Sediments activity. Now, as you work through this, you will have noticed that it really asks you to start thinking about what's actually happening based on data that they give you. Now, in science, we call this processing and analysing. Right there. And the ability to communicate our understanding. Now, it's important that when you're doing these activities, you understand how they're going to actually help you and give you a chance to gauge your understanding and what sort of level of achievement you're showing so that you can report back to us later on. Now, when it comes to processing and analysing data, it depends on whether or not you can, number one, answer the questions based on the data, and that would be about a C level. And number two, can you actually justify it by using the data and explaining how that supports your answer? And this can give you either a B or an A level, depending on how well you do this. So let's quickly go through the activity and see what's down below. We've got the river here. It's coming down from the mountains up the top. All of these tiny little creeks are running into one big river that goes down to the sea. Of course, the rocks which are being broken down in the mountains are being washed down this river. And depending on the gradient, you'll have different speeds of water flowing at different parts in the river. So first of all, we've got Bill Shack up the top. Then we've got the boat ramp here in the middle. Then we have a coastal plain down here. We took some more rocks at Sandy Beach. And then the river empties out into the sea. And you've been given some data from rock samples taken at point A and point C. Now, as you know, if you've got rocks breaking down up here in the mountains and getting washed down the river, first of all, when they first break down, they're getting quite big, but they can be ranged from quite big to quite small. So you have to remember that. Number two, the size of the rock will depend on how far it's getting carried down the river. You see, light, tiny rock like sand can get carried for a long way because it's very light and can easily move in water that's not even moving very fast. However, big rocks tend to need a lot of faster moving water because it needs enough energy to pick the rock up and move it down. So you're going to see a difference in the type of rocks that you find at point A and point C. Let's have a look at the data. Here we go. You had to actually graph this data. Now, if you read this right, you'll notice that it says here particle size, and it's going from 8 to 16, and then down here, less than 0.025 in millimeters. Now, this is because they didn't want to measure every single type of rock. They just wanted to measure them in groups. It's a lot quicker. Now, this, if you read it right, means that the rock size is going down as you read down the table. Now, that's something that might have stuffed up your graphs if you didn't get that right. This column here is A, Bill Shack, and this column here is C, Sandy Beach. Now, as you can see here, Bill Shack has some bigger rocks here, bigger rocks, a lot more bigger rocks, lots of bigger rocks, less bigger rocks, less of bigger rocks, and then no small rocks at all. Sandy Beach, however, doesn't have any big rocks. However, it does have a gradient of small rocks deposited there. So on your graphs, you should see this sort of trend as you put out that data, and this is what it should look like. Here you go. So as you can see, down here is the small rocks up to the big rocks. So if I draw an arrow here to indicate size, that helps you get your head around that. So small to big. At Bill Shack, we have only the bigger rocks, and at Sandy Beach, we have only the smaller rocks. Now, then you had to go and answer these questions. Now, 4 and 5 are your chance to really show your understanding at an A level if you do it with enough detail. So I'm just going to quickly talk to you about how to do that. Question 2 was identify the site where all the sediment had mainly smaller particles. If you can read a graph and make a decision on that. If you said site C, then you are definitely getting a C level standard there. Discuss the differences, so be able to compare the two sites. Now, if you just told me that site A has a bigger range compared with site C, or site A has a lot smaller particles, bigger particles than site C, then I would give yourself a C. However, if you gave me even more detail like this and really were specific about it, then that's really looking at a B level for using your data, B to A level actually, for using your data to justify it, okay? So that's on the way up to an A. Now, with here, it asks you to propose why there were differences. Now, if you talked about the fact that rivers, again, need to be able to carry the large particles, and they can only do it when it's flowing fast, so you relate that to the mountains and stuff, because when it's up in the mountains, it's going to be on a steep gradient, so the water's going to be running fast with lots of energy. It'll be able to pick up the big particles. Gravity will be pulling them down too. Then that means you're looking at an A standard here. Small particles can be carried much further, all the way down to site C. So if you actually related it, the size of the particles, to how fast the river was flowing, and really used your understanding to answer that question and related it back to the environment that it came from, you're definitely looking at an A standard there. If you gave me a part answer there, or talked about the fact that the bigger particles would have been deposited first and therefore they wouldn't have made it down to site C, then that would give you about a C standard there. Now, the last but not least, can you predict what the sample sizes would be in point B, right here, in the direction of the flow? And it's quite a simple answer when you think about it in the big picture. If all of the big particles have been deposited at the first site, then you're only going to have middle to small particles at the second. So if you actually talked about it being between, okay, then you could definitely give yourself a C. If you then went and related it to current speed, how steep the gradient was, talking about the particle sizes needing a decent amount of current to be carried down that far, but they'd definitely be smaller than the ones were at site A because they've been dropped off there, then you're looking at a A level standard there. Okay, good luck.